Electrical safety. So this is another part of the operational procedures domain. We have to understand electrical safety because as computer technicians, we're going to touch electricity, right? Uh, Electricity is dangerous, as you guys know. You can shock yourself. For humans, we want to make sure that we check our outlets to make sure they're working properly. We have to verify that our outlet has the right power. So here in the US, we use 120 volts AC. If you go over to Europe, they use 230 or 240 volts AC. Okay? If you plug in something that's designed for 120 into something that is giving you 240, you're going to overpower it. I had a friend when I was in the Middle East, he brought his Xbox over, which is made by Microsoft, which only supported 120 volts AC as the input. He plugged it into the wall that had 240 volts. He blew the power supply. He no longer had an Xbox. So you don't want to do that. You have to use a transformer to step it down if that's the case. The nice thing is with most of our computers, we have dual voltage ability on our power supplies. So it's either a switch that you flip that will tell it what the input is, and we'll cover that in power supplies, or they're auto-sensing where they'll adjust automatically. Laptops are all auto-sensing. So I can plug it into any outlet and it'll work between 120 and 240, and it'll work just fine. Don't pull your cords out by the wires. I know you guys, if you've seen kids, they do this all the time, right? They grab the cable and they yank it from the wall. What ends up happening is you end up fraying the cable or breaking the cable. But worse is when you fray it, because then you go to grab it the next time and your hand hits the copper in the inside and you get shocked. So pull it by the actual rubber plug at the end. And don't use frayed cables, because frayed cables either can hurt you, hurt someone else, or they can cause fires. For computers, you have to use surge protection, right? Higher rating in joules is best. So if you see something, the bigger the joules number means it's going to have more protection for you. So if your house gets struck by lightning, you can have a surge which can then go through the power lines and fry your computer. By having that surge protector, it's going to cut that and not get to your computer. Don't overload your surge protectors. I'm sure you guys have all seen this. We got the 6-port power strip, right? And you've got like one strip plugged into another strip, plugged into another strip, because there's not enough ports on it. That's dangerous. Don't do that, right? That's adding too much resistance. More resistance adds more heat. More heat can then create a fire. So you want to have one surge protector going into one wall outlet, right? Don't put too much stuff into one protector. Really common during Christmas time, right? Because we all use all of our outlets already, and then we decide we want a Christmas tree too. So people start doing surge protector to surge protector to surge protector. Also, for a computer, highly recommended to use a an uninterrupted power supply, a UPS. This is what it'll do is when you lose power, it runs off a battery to make sure your computer doesn't shut down. And this is something that a lot of people don't realize. You don't want to use an UPS for laser printers. So if you have a printer like the one in the back of the room here, those things being plugged into an UPS, they'll drain the UPS too quickly, and they can actually cause problems for the UPS and destroy the UPS. Laser printers are not designed for UPS. They take way too much wattage. So power supplies and electrical safety. Inside your computer, the thing that has the most voltage that you're going to work with is the power supply. Okay? They look like here on the right. You see the little metal case here? That's usually how you'll handle them. You do not want to open up a power supply. If you want to look inside and see what one looks like, go to YouTube, watch a professional take it apart. They'll show you what it looks like on the inside. The problem is, even once you unplug it, there are some capacitors inside these power supplies. Okay? Capacitors hold charge even when they're unplugged. And so if you stick something metal in there and touch the capacitor, it's going to discharge the capacitor. And if you're holding that metal thing, it's going to discharge into you, which means you're going to get shocked. Big voltage here. If it's broken, we don't fix these things. They're replaceable parts. They're cheap. Okay? You need a new power supply, go down to Micro Center, 20 to 50 to 60 bucks, you can get a brand new one, right? Pop out 4 screws, pop them back in, you're ready to go. Just take the entire metal box, take it out, put a whole new one in. Long after you turn off the computer, the capacitors in that power supply still have lots and lots of voltage. They will hurt you. And again, look on a website or YouTube if you want to be able to see what the inside of one looks like. It'll show you what they look like, and you can see what it looks like on the inside. Electrical conditions. So you got to understand the electrical conditions terms for the A+ exam. So I have a cheat sheet up here for you. On the left side is the term, the center is the description, and on the right side is what you would do to fix the problem that I'm showing you on the left. So for instance, a power surge. Like we said, the power goes up. It's a short increase in AC voltage. So if we start at 120 or 130, which is normal US, and we jump up, we're going to then have what's called a surge. Okay, it's just kind of a minor hump. Think of like going up a hill. Okay, not going up a mountain. If we had a spike, on the other hand, it would be very, very high jump. We might go from 120 to like 200 or 300, right? We have a big jump. That's more like the mountain. Dirty power. Dirty power is not a huge deal here in the US, but it is a huge deal overseas. What dirty power means is we expect 120 as like kind of more like a flat line, right? It should be somewhere in that 118, 119, 120, 121, somewhere in a couple of volts, right? Well, if you go overseas, you may see things jumping up and down fairly consistently, more like a wave. For instance, I was in the Philippines for about 4 or 5 weeks, and the power there tended to go down to 110, up to 130, back down to 120. It just kind of slowly went up and down. Now, your computer can deal with that, but it puts extra strain on the power supply. So to overcome that, you want to use either an UPS or you want to use a line conditioner. And what a line conditioner does is it actually takes this wavy power and turns it into a straight line. So when it gets to your computer, it's a nice straight line, which is what your computer wants. If you have a high-end audio-visual system, a lot of guys will buy line conditioners for that purpose because those line conditioners will keep it nice and steady, and it gives it a better high-quality audio sound for their audio systems. A sag is a short duration that kind of dips down. So remember we talked about those hills. Going up was the power surge. When we come back down, that's the sag. And so the sag, we might go from 120 down to 115. It's not enough to drop your computer, but the power just dipped down a little and then comes back up. If we have a larger dip than a sag, maybe we go from 120 down to like 80 or 90 volts. That's called a brownout, where it drops lower, usually anywhere between 50 and 70% of value. And that can be low enough that your computer will actually drop from it. Okay? So you're worried about that. A blackout, on the other hand, complete loss of power. We go from 120 to 0. We're just gone. And we'll use an UPS for that as well, or we can use a backup generator in large environments. And I'm going to show you each of these protective measures in detail on the next couple of slides, but this is kind of the big overview cheat sheet for you. So, surge protectors and surge suppressors. These are the typical power strips you guys see that we use pretty much everywhere. There is a difference between a power strip and a surge protector, though. A power strip, all it does is it converts one outlet to 4 or 6 outlets, right? A surge protector will actually have the protection for that surge where it'll trip off and protect the devices connected to it. If you go to Walmart and you get one of those like long strip power strips, they're like $3 for a 6-port, those usually are just a power strip. It's just converting one outlet to 6. There's no protection. Usually if you're going to get a surge suppressor or a surge protector, they're going to be somewhere around $8, $10, $12 or more. And they'll actually say it on there how much protection in joules. Bigger joules number is better. It's going to absorb the overvoltage condition. So any kind of spikes or surges are going to get cut off by that and not hurt the connected devices. UPSs take this a step further. They'll do that function, but in addition, they have a big battery in there. And so it's going to provide you emergency power so that if you have a power failure, either a brownout or a blackout, it's going to be able to continue to run your computer. The UPS will run your computer from its battery continuously, and it recharges its battery in the background from the wall outlet. And so the standby power supply is not an UPS. It's like an UPS, though. And what it does is it's actually going to run it from the wall, and if the power goes out, then it switches to battery. UPSs are better because they provide that line conditioning function because you're constantly getting it from the battery, and then the battery is being recharged from the wall. With an SPS, it's just going to come from the wall, and if it cuts out, it switches over to the battery. Slight difference, but not too big of a deal. For the A+ exam, they're always going to talk about UPSs. They don't usually talk about SPSs. I bring it up just so that if you're looking for your own use and trying to figure out what to buy when you're at Best Buy, you can know that there's a difference between the two, and UPSs are better. You always want to make sure you have UPSs on your critical systems like servers, because those aren't supposed to be down, right? So usually what we'll do in a server room is you'll have a server plugged into an UPS, and then the UPS plugged into the server facility, and the UPS will give you usually about 7 to 10 minutes worth of uptime when the power goes out, enough time to get the generators up and bring the whole facility back online on generator power. So some terms that you'll see with UPSs when you go to buy one. You have things like run times, and that's how long will this thing last, okay? Usually you want 15 minutes or more. Bigger batteries are going to cost more, and they're going to stay up longer, okay? The way you calculate this is based on how much wattage your stuff is going to drain. The more wattage you're using, the less time the battery is going to remain up. Network support. Some UPS actually have network support as well, so that they actually can detect the power outage and then send a message to the devices on the network over the network connection that says, hey, this server is going to be shutting down because we lost power. And it gives everybody a warning because now the domain controller is going to go down or the file share is going to go down. A lot of them have automatic shutdown. So if you have your personal computer, a lot of these UPSs, like this one on the right, will have a USB port on it that plugs into your computer as well. And so if it detected that the power went out on the wall, it's providing battery power to your computer still, but it sends a message to your computer saying, hey, we lost power, so I'm going to shut you down, right? And so the computer will now be able to do a safe shutdown instead of just having the power yanked away from it. Because again, we can't run off the UPS continually forever. We only have 10 or 15 minutes worth of time. And then we have surge suppression. UPSs do have that surge protector, surge suppression capability as well on designated outlets of it. So for instance, on a lot of consumer grade ones, you can see here on the back, on the left side here, the top part is not providing battery backup at all. It's just a surge protector. So we probably want to plug in our laser printer over here, hence the little printer icon, right? On the bottom is where our battery backup stuff is being provided. So on the bottom, I'd probably want things like my computer and my monitor. And on the top, on the surge only, I would use things maybe like my modem and my printer, stuff like that. Because again, the more stuff you plug in on the bottom on that battery, the faster that battery is going to drain down. So we plug everything into the battery, then everything is considered crucial. It's going to drain our battery really quickly. So how do you calculate the size of an UPS? This way. No. So the UPS, the UPS, is calculated in what's called volt amps. You calculate that by adding your wattage of a computer and your monitor and multiplying by 1.4. If your power has already provided you in amps, you would do the amps of the computer times 120 volts, which is what our power is in the US, and that gives us volt amps. So a good example of that is here I have a 630 volt amp computer, which has a 450 watt power supply. So what they did, and they have a 108 volt amp monitor, which was a 9 amp draw for that monitor. So we would use the bottom calculation with the 9 amps times 120, giving us 108. On the top, we have our watts for computer times 1.4 gives us the 630 volt amps. Add those together, that gives us 738 volt amps. So we want to multiply that by 2 and get something around 1500 volt amps, which would be something like this small UPS down here at the bottom that you could buy for about $50 to $100 at Best Buy. The good news here, you're not going to see a test question on this. Okay? This is just for you in the real world as you're trying to figure out, you have a customer who says, I want an UPS for my computer. Which kind of UPS do you buy? You go to Micro Center, they've got 30 or 40 different choices. This is how you actually calculate it. You look at what do you have, how much do you need, and off you go. And again, bigger is always better, so when in doubt, go big, right? Cost a little more and they're really heavy, but other than that, there's no real problem with going big. Power conditioning devices. So I had mentioned line conditioners. This is what a line conditioner looks like. Okay. Basically, as your power is coming in, if it's a little bit high or a little bit low, line conditioners can bring that back up to a standard level. So it takes those waves and makes them into a straight line. They take the underpowered stuff and bring it back up to normal, or they take the overpower and lower it back down. And it uses an electrical component called a rectifier to do this. If you're in a computer server facility, they're going to have large line conditioners in place because they want to make sure these computers are getting the right power all the time. Because if you have these spikes and drops, you can actually damage the power supplies and they'll drop offline. If you're using an inline UPS, it's going to perform this function for you already. So you don't have to worry too much about it. And like I said, if you're dealing with any high-end audiovisual systems, people like line conditioners because if you have the power is not solid and it's going up and down with those waves, it's going to have bad effects on your audio system. So you'll actually audibly hear that hiss and that noise, and this will take a lot of that out for you. All right, fire suppression. So the other thing that comes with power and electricity is fires, right? A Class Charlie fire, Class C fire, is an electrical fire. And if you have a computer or an outlet that catches fire, you don't want to spray water on it, right? Because that would spread the electricity even more. And you'll damage your computer completely. Instead, we want to use CO2. And what CO2 does is it's going to use carbon dioxide. It's going to push out the oxygen away from the machine, suffocating the fire and allowing the fire to go away. I'm sure you all have seen the nice red fire extinguishers all over the place. That's what a CO2 fire extinguisher will look like. If it's a small fire, go ahead and grab the fire extinguisher and try putting it out. If you think you're going to get hurt, don't do it. Just run away and call 911. That's okay too, right? If you're in a server room, you need to be aware that we use either CO2 or halon systems in server rooms, okay? So what that means is usually there will be a red light that spins around like a fireman's light, and if the system is going to go off, that light will start going on and whistles or bells will go off. What that means is drop what you're doing and get out of the room, because in the next 15 to 30 seconds, that room is going to fill with CO2 or halon and suffocate you, okay? The reason why is if we have a fire in a server room, we need to put that fire out really quick or it's going to spread to all the other critical assets. And so all these systems, they have raised floors and drop ceilings, and they have all these systems set up so that it will just completely fill the room very, very quickly with this CO2 or halon and suffocate the fire. So if you're working in there, get out, okay? So that's pretty common in server rooms, and they will have to have some sort of warning on there. For instance, there's a sign here that says, hey, we have a halon system in use. Halon is not as popular anymore in the civilian world. I think they said it was carcinogenic, which is why it's been removed from most civilian places, and they've all converted over to other chemicals or CO2. But the same system applies. The idea is they're going to get the air out of that room, which means you're going to suffocate. So don't hang out in that room. There you go. All right, so here is our sample question. What do you think would be best protect the equipment from power spikes? An anti-static mat, an HVAC system, a surge suppressor, or a power strip? C, yeah, surge suppressor, right? What's an HVAC system? HVAC?
That's air conditioning.
Air conditioning, right? Again, they like to do that kind of stuff, throw an acronym out there and see if you bite, right? Because that kind of looks like halon, right? So maybe it would have gotten somebody. So, but no, it is a surge suppressor. You are correct. It is C. Power strip, all it's going to do is give you more outlets. Surge suppressor is going to stop that spike.